Hi everyone, and welcome back to 4th grade science. Today we're going to speak about the solar system. We're going to discuss everything that has to do with it. Because as I have told you before, this term we're going to use it to study space and any types of phenomenon that happens in it. Okay, we're going to talk about how stars were born, how they die, what are black holes, why do we know about them, why are they important towards existence, and so on. So, the solar system. What do we know? We know that we have 8 planets that compose our solar system and all of them revolve around the sun. What else? We also know that each planet has a rotation and revolution period. We're going to discuss today how long does it take for each planet to give one entire spin around the sun. So, with no further ado, let's start with the Big Bang. And for us to discuss the Big Bang, since it's a space theme, I thought that maybe we could use this sound. Okay, no, jokes aside. Okay, the Big Bang. The Big Bang was this incredible event that happened eons ago in which everything came into existence. So, the Big Bang theory explains how the universe began as a single point and later stretched to the gigantic size we know today. When I say the Big Bang theory, I'm not talking about the TV show, which is very good, but I'm talking about the theory itself. A theory is an idea that we have of something. Okay, every time that we think about how a process came to be or how something is done, we have a theory in our heads. We try to prove that theory with several experiments or with any type of physical evidence. So eons ago, everything was nothing. There was no light, no life, no sound, and no time. Suddenly, minuscule forces were acting on one another, and the universe expanded into existence. In a matter of seconds, stars and galaxies were formed from a single atom. Everything started so suddenly, we could say that it started with a big bang. Okay, that's why we call it the Big Bang, because we theorized that there was this huge explosion, this huge bang, and suddenly, in a matter of seconds, we had planets, we had asteroids, we had nebulas, and so on. Okay, this is a GIF that shows you what we think it looked like. There was a huge explosion of light, of energy, and then little by little galaxies started to form. You see those little lights, those little dots that are moving and in a spinning motion? That's what we think are the galaxies and how they came to be. Now, our solar system. Our solar system is composed by 8 planets. They all have different revolution periods. Some of them have satellites, natural and artificial satellites, and they revolve around our planets. For in case of the Earth, we have one satellite, which is the Moon. It's a natural satellite. And then we have several made by men, which are the artificial satellites. So one of them, I think, it's the Hubble. What's the word? I forgot that word. It's not observatory, it's Hubble telescope. That's the word. So, the sun is the center of our solar system. That's why we call it a solar system, because everything that composes it surrounds the sun. The sun is a medium-sized star at the center of our system. I know it's hard to comprehend that the sun is actually not that big, but in the entire universe that we have not yet come to explore completely, we know that there are bigger stars like Betelgeuse or Arcturus. This big ball of gas, like every star, it is a big ball of gas, has a very powerful gravitational pull, making any nearby celestial object spin around it. When I say celestial object, I mean anything that might be floating in space. Satellites, planets, asteroids, meteorites, etc. Stars, since they are this huge ball of energy, they have a great gravitational pull. That's why there are several solar systems in our galaxy. Now, a satellite, I know that I have said this word several times before, but I have not explained what it is. A satellite is an object that revolves around a larger body in space. There are two types of satellites. One are natural satellites like our moon. It's a natural satellite, and the artificial satellites made by humans. We have several. Many of them are even space stations for astronauts to go into space and check around. Since they revolve around the Earth, we can consider them satellites besides considering them spacecrafts. Now, the planet movements. There are two types of movements in our planet. First, rotation. When a planet or moon turns all the way around or spins on its axis one time, it's called a rotation. The axis is an imaginary line that goes through the top of the planet to the bottom of the planet. It's like a metal rod stuck in the middle of a planet. So, this movement that it does on itself, for example, if we grab our hand and we move it in a clockwise motion, that is the movement that our planet is doing. That is a rotation. The period of rotation changes from planet to planet. It's not the same for everyone. For example, Earth takes 24 hours to do so. The Earth axis of rotation is tilt. That means that it's not straight. This tilt causes the different seasons of the year. As we know, for example, Venezuela is located in the equator of the planet. So we are always receiving full-blown heat from the sun. We are always receiving directly those rays of sunshine, while the rest of the world is a little bit more inclined and in different places. So depending on their location and depending on the movement of the Earth, they are going to have different seasons, what we know as spring, summer, fall, and winter. Now we have revolutions. Revolution is the movement that a planet or moon, when a planet or moon travels around the body, it's orbiting one time, okay? Remember how in the previous slide I explained that we could pretend that our hand is the planet? If we move our hand in a clockwise motion, that is the rotation movement that the planet is doing. Now, besides that, I have this cup of water. The planet revolves around the sun. Doing this movement means it's a revolution. Now, doing both movements at the same time, I cannot roll my hand in a 360 angles. I'm sorry for that. Let's pretend that I can. This movement, along with revolution, is the two types of movement that always are happening in our Earth. If we stop moving, it would be a disaster. Several natural disasters would happen. We would probably die because a sudden has, with the physics, the inertia of our bodies will propel us forward 100 kilometers per hour. Now, the Earth moves in its orbit, which is a fixed path around the sun. Okay, it cannot move as it likes. There's an elliptical formation around the sun, and it's always going to move in that same path. An orbit is the curved path of a celestial object or spacecraft around the star, planet, or moon. Okay, so we do not only, the Earth revolves around the sun, but for example, our moon, our dear moon, revolves around us. The Earth takes a full year, 365 days, for one complete revolution around the sun. Now the planets. We can divide the planets in two types of planets. The inner planets, those who are closer to the sun and closer to Earth, and the outside planets, which are a little bit further away from the sun. Okay, the inner planets have one common characteristic. They are hot planets, they have high temperatures, and they are made of solid rock. Okay, those are Venus, Mercury, Mars, and Earth. Let's start with Mercury. We're going to see the planets from closest to the sun to farthest away. So Mercury, we call it the smallest planet because in comparison to the size of the other planets, it's the smallest. It takes 88 Earth days for this planet to complete a revolution around our main star. Okay, remember that time is a construct that we humans made for ourselves. The concept of time is a little bit vague, so we're going to try to talk about the revolution periods of each planet using human time, okay, the one that we have established. So it says here that the Mercury has only 88 days to complete a revolution around the sun. That means that in Mercury, an entire year is only 88 days. During the day, it reaches temperatures of 427 degrees Celsius and dramatically lowers it at night, reaching minus 179 degrees Celsius. Our bodies can only sustain about 50 degrees Celsius. If we go over that, we're probably going to die. So there's no way we can't visit Mercury. It's too hot for us. And this planet has no moons. Now Venus, we associate Venus with love because most of these planets are named after the gods of Roman mythology. Venus in this case was the goddess of love for Romans. It is the hottest planet. It's too hot for us to ever get to Venus. For example, then Venus reaches a temperature of 471 degrees Celsius. That's way more than our body can sustain. Venus' atmosphere is made out of clouds of poisonous gases that cause a severe global warming. Okay, so besides the planet being incredibly hot, let's pretend that we could sustain that type of heat, that our body could go to any planet and sustain temperatures that go over the 400 degrees Celsius. Even if we were there, we would not be able to breathe because the entire atmosphere of this planet is made of poisonous gases. There's no way for us to visit Venus. That's why we try to go to Mars. It's closer and it's a little bit colder. It takes 225 days for this planet to complete a full lap around the sun. Okay, so in Venus, the revolution period, which is an entire year, is 225 days. It also has no moons. Now, home, what we call the planet Earth. It is the only planet, as far as we know, that is able to sustain life. Okay, why is this? Because in here it says that the average temperature of the Earth is 14 degrees Celsius. Okay, we're in Venezuela. We know that we often have common temperatures of 23 to 25 degrees. But if we make a study about the entire planet, we can assume that it's only 14 degrees average. Now, we are far away from the sun, but close enough that the heat that it radiates is enough for us to sustain our life, for plants to grow, for animals to live, for us to go around the entire planet. The reason why we're alive is because we are at the perfect distance from the sun. If we were to move 1 kilometer closer to the sun or 1 kilometer farther away from the sun, it would have terrible repercussions in our entire ecosystem. And we only have one simple moon. We call it Selene. It is also the only planet of our solar system with liquid water on the surface. Okay, we have, in recent studies, we have discovered that Mars used to have water, but nowadays in its surface we have no water in it. Now Mars, we call it the red planet, but why is it red? The coloration is due to a constant process of oxidation on the planet's surface. Okay, remember how when metal gets very, very old, it gets this really orange texture on it? That's called rust. That's a result of an oxidation process. In the case of Mars, the minerals that are over the surface of this planet do not properly interact with oxygen. I know there's not the same enough oxygen as there is in here on Earth. We would not be able to breathe on Mars, but there's a little bit oxygen in its atmosphere. So these minerals interact with oxygen and they rust. And that's why the entire planet is red. It takes 687 days to complete a revolution. We have yet not been able to stand on the surface of Mars. We have been sending rovers, which are little robots that have been exploring the surface of Mars, and we're going to review a little bit more of information about them in a future class. Mars holds an oscillating temperature between minus 60 degrees to 125 degrees Celsius. It also has two moons, which are called Phobos and Deimos. Now the outer planets. These guys are gigantic, but they are also made entirely of liquid and gas. The thing is that the temperatures are so low because they are so far away from the sun that the liquids condenses. Let's remember that class that we had about the water cycle, in which we know that matter, like water, has three stages: gas, solid, and liquid. When it's rain, it falls as water, it's liquid, and then it evaporates because of the heat, transforming into gas. Gas and liquids can be condensed if the temperature is low enough. Okay, so Jupiter, we call it the king of the planets because it's the biggest planet of our entire solar system. It was also named after the king of the gods of the Roman mythology. Gases are held in a condensed form under an average temperature of minus 145 degrees Celsius. Jupiter has a gravitational pull that holds 79 different moons. Okay, we only have one, Mars has two, and Jupiter has 79. That's way too much, but that tells you how big the gravitational pull of Jupiter is. The gravitational pull is the ability to attract, because of gravity, different objects in space. Now, it also has something called the Great Red Spot. If we see the planet, you're going to see on the lower half this big red stain. But what is it? The Great Red Spot is a storm that has been raging in Jupiter for 300 years. Okay, this planet, this storm is older than your great-grandparents, older than your great-great-great-great-grandparents. It has been here for generations, and we are still not sure what originated this entire storm, but it continues to rage, and we can see it from far away using special telescopes. That big is that storm. Now let's go with Saturn. It's called the ring planet. Other planets of the solar system also have rings, but we call Saturn the ring planet because its rings are more noticeable for us from Earth. They are easier to see. It is 10 times as wide as the Earth, and its surface is completely made out of gas, liquids, and crystals. Okay, the entire planet is less dense than water. That means that if we had an ocean big enough to hold Saturn, we could place it on the surface of the water and it would not sink. We could put an entire planet on the surface of water and it would not sink because it's made entirely out of gas. It's less dense than water. It has a temperature of minus 178 degrees and it holds over 50 moons, which I do not know the names of. Now Uranus. Uranus is the sideways planet. Why? Mercury and Uranus actually revolve in a different direction than the others. While the others go around the sun counterclockwise, these ones go clockwise. With a temperature of minus 223 degrees, it is considered the coldest planet of the entire solar system. Not only has a revolution period of, I got distracted. It does not only have a weird direction for its revolution, its rotation is also sideways. Instead of revolving like all of it does horizontally, this one does so vertically. Most of Uranus' surface is made out of ice because, as I said, it's so far away from the sun, the entire surface of this planet has no liquid, okay? It's completely made out of ice. Uranus is the only planet that it's not in the same position as the others. It even spins vertically, just like I said. And it also holds 27 moons. Now, our last planet is Neptune. Neptune, we call it the blue planet. You may be familiar with the term blue planet referring to the Earth. It's also true. We call our planet the blue planet because of the big oceans that cover the surface of the Earth. But Neptune is entirely blue. That's why we sometimes call both of them the blue planet. It takes 165 human years to complete one revolution around the sun. So if we were to live in Neptune, we would probably not get to 1 year old, okay? Humans, we live in between 90 to 100 years, that's our life expectancy. And we would not make it to 165 years. That means that we would probably die at 7 months old in Neptune. The winds on this planet are incredibly powerful. They are even able to break the sound barrier. Okay, they just blow very fast and very hard. This planet holds 14 massive moons. They are a little bit bigger than our usual moons, like the ones from Jupiter, ours, the moon, Deimos, Phobos, and so on. Now, you might remember that there before was a 9th planet, which was called Pluto. But NASA decided to make a short list of conditions that every planet must comply with to become a planet, to have that title. First, it must orbit a star. In our cosmic neighborhood, it's the sun. It also must be big enough to have enough gravity to force into a spherical shape. Okay, have you ever wondered why all of the planets are circular, why they are circles, why they're a big sphere? Why are they not square planets or cone planets? It's because the gravity of itself pushes it and compacts it into a perfect circle. Now, it also must be big enough that its gravity cleared away any other objects of familiar size near its orbit around the sun. Okay, so that means that there must not be any object bigger than itself, bigger than that planet, revolving in its path, okay? Sadly, in the case of Pluto was not big enough to have a perfect spherical shape like the other planets, and it's not big enough to clear away its orbit. In its orbit also revolves Neptune, which is a bigger planet. And because of that, we decided to change the status of Pluto to a dwarf planet. And sorry, Pluto, you just did not make the list. Now, guys, your homework is a Google Forms questionnaire. It's only 10 questions. You can find the information in the reading that I have linked in, uploaded to Academia. And I have also uploaded this presentation for you to check later. Here's a small joke about Mars and the Earth, talking about how many moons they would like to have, as if they were children. And Earth is a little bit concerned about Jupiter's amount of moons, which is comprehensible. It has 79. So that was it for today. I hope you had a wonderful, wonderful week. See you guys in next class. Bye.